Hey, welcome back to the shop. I wanted to make a set of boring bars for a very long time. These are 12mm boring bars that fit my tree pond tool holders, or should. These are 10mm boring bars also for the tree pond holder with a reducing sleeve. And these are 8mm boring bars that fit my Wohlhaupte boring head. Each size has one with the cutting bit at 90 degrees for through holes and one with the cutting bit at 45 degrees to machine up to a shoulder. All are machined from drill rod and take a 3mm high-speed steel or carbide cutting bit. The bigger ones are the 12 and 10mm boring bars are slit in front here and have a clamping screw here to clamp the cutting bit. And the small 8mm boring bars are drilled through and the cutting bit is clamped with a set screw from the back, because I didn't have room for a clamping screw in front here. If you want to see how these are made, hang around. I will show you. Okay, first step is to face the parts to length and put a nice chamfer on them, so they are nice to handle. Okay, now as we have the raw stock faced to length, we're going to drill and ream the holes for the cutting bits. I want to use 3mm high-speed steel and carbide cutting bits, so we're going to drill and ream it to 3mm. I dragged out my collet block, shop-made of course, and I already clamped up one of the 12mm boring bar blanks. First we will do all the drilling for the 90-degree boring bars, and then we will do all the 45-degree boring bars, and then we will do the clamping thread on the two bigger sizes. And obviously we will cut the slit, the clamping slit. So let's go to the mill and do the setup. Okay, when I do setups like this, I like the workpiece against the stop, not the collet block, because that way the actual stick out of the collet block is not critical. If I have it overhang that much, it's the same as if I had only 10mm or something like that of stick out, and that makes for faster working. So I clamp the part in the collet block, I tighten it down, then I just slip it up against the stop and clamp it. And now the nice thing is, I only have to loosen the nut, pull out the workpiece and push in the next workpiece up against the stop, and I don't have to disturb my setting on the collet block itself. And we're at finding the center and the end of the piece. Okay, we're going to drill and ream a 3mm hole. I moved in 2mm minus the radius of the hole. We will have 0.5mm of wall thickness left to the end of the boring. we go. Drilled 2.8 millimeters. And now we follow it with a 3 millimeter reamer. Reamer, of course, low speed. And a good amount of oil. Okay, that's my setup for the 45-degree drilled boring bar. Okay, that's my setup for the 45-degree boring bars. Just clamping down the collet block. And while the Y direction is still valid, the X direction, of course, is somewhere. But when I turned the parts to length, I machined a pretty big chamfer on the business end of the boring bar, and that's what we're going to use to get our new X coordinate. And we will just line it up by eye. I have my starter drill in here, and we can just move it until the tip of the drill is in the center of the chamfer. Okay, that looks about right. So let's start with the spotting drill at a proper speed. There we go. Okay, I drilled and deburred all of them, and I have a 3mm high-speed steel blank here, and you can see these are the 90-degree ones with the tool very close to the edge, but you can still not machine a flat-bottomed hole with these, or machine up against the shoulder, because the boring bar itself would hit bottom before the cutting edge. For that you need this style, where the cutting bit is at 45-degree and it's sticking out to the side and to the front of the boring bar. And with this one you can come in, bore up to a shoulder, and face in or face out, whatever you want. Next we will finish the smaller boring bars by drilling them from the rear and tapping the rear end, and then we will make a push rod that goes in and holds the high-speed steel blank in there. So let's go to the lathe. Okay, next step is to drill these boring bars from the rear all the way up to the cross hole, at least the small ones. And that's to clamp the cutting bit with a long push rod and a set screw in the back. So let's do this. And as you can see, this is about 50 millimeters long, and we need to drill in with a 3mm drill. And that's quite deep. That's 15 times diameter deep, and when you're drilling that deep with such small drills, take your time, pull the tool out quite often and use plenty of oil. Otherwise you will seize the drill bit, especially when you drill deeper than your flutes. And you will see that I start with the drill bit clamped up short, and then I will pull it out farther and farther out of the drill chuck. And in fact we start with a 2.8mm drill bit, and then I will run a 3mm drill bit through to clean it up. I'm not going to ream it because I want the push pin in there to move freely. And my reamers produce a very close sliding fit. So not good. I wanted to slide free. To pull out the drill a bit more. Now we're clamping only on the last 10 millimeters of the drill bit, of the shank, and because of that you can't start with the drill bit extended that wide out because, as you see, it gets quite flexible. Okay. Whoop. Okay, we're through. Now we change to a drill, 3mm drill, and clean up the hole. There we go. Now we open up the end to 3.3mm. And tap it. 4mm thread. There we go. Okay, let's take a look. I drilled both of the boring bars, the small boring bars, completely through, and I tapped the end for an M4 thread. Then I cut off some drill rod, 3mm drill rod, which slides freely into the end of the boring bar, like this. And the same for this one, with only one difference. I filed the end to an angle of 45 degrees. Because the hole in this one is of course 45 degrees. Now we will assemble them. First we take the push pin, we drop it in the end, and we take one of the 4mm set screws and we screw it in. And we take a high-speed steel bit. This is 3mm high-speed steel, cobalt 12, that's 12% cobalt. One of the highest grades high-speed steel you can get. Obviously these are too long, I have to cut them down just with a small cut-off wheel. And it goes in here. And when we tighten down the set screw back here, we push the pin inside the boring bar to the front, and obviously lock the cutting bit in position. And when we loosen the set screw like this, we can of course pull it out. And get it back in, back out, change our bits, get it back in, regrind it, whatever we want, put it back, tighten the set screw. Doesn't need much, not much torque. I'm just like this. And this should be more than strong enough to take that small cutting forces. And when you wonder what I need these 8mm boring bars, pretty short ones, yeah, now it's obvious, huh? For my Woolhop, the boring head, which takes 8mm tooling. And of course in a boring head you want as short as possible stick out. and that's 35 millimeters working depth, I think. Yeah, about 35 millimeters, and that's for a lot of jobs good enough. I have some boring bars that are longer with 8 millimeter shank, also some carbide insert boring bars, but the inserted boring bars have the problem that they introduce a lot of cutting pressure, and with boring head that's always a bit of a problem. And the 45-degree one works just the same. We take the push pin, get it in front, take our cutting bit, set screw in back, and tighten it down. And the 45-degree end on the push pin aligns itself with the cutting bit and should lock it in. Yes, locks it in position with just a little bit of torque, and releases it also. So you set up your cutting bit like this, so it protrudes slightly above the edge of your boring bar, and you're good to go. And then you tighten the set screw back here. When you want to change the bit, you loosen it and you pull it out. So these are the real locking boring bars. But obviously we can't do this to the long boring bars for the lathe, because that would call for some serious deep hole drilling, and that's 110 millimeters deep, and drilling 110 millimeters deep with a 3 or 4 millimeter drill bit is really no fun without special setups. So we will set them up on the milling machine again. We will drill and tap a hole 90 degrees offset to the first hole, and then we will slit them so we can clamp the complete front end down with a single screw. I didn't want to do this with the smaller boring bars because there is not much material for a screw in front. But with the 10 and 12 millimeters, this should work. This should work out fine. Okay, I set the colored block up high above the vise, and now we will drill and tap the clamping hole thread thing, and then we will flip it 90 degrees, then we drill the relief for the slot, and then we will flip it back and cut the relief slot with a slitting saw. So let's get started. First of all, we need to align it so that the cross hole for the cutting bit is kind of square. And for that we can of course use a cutting bit, and I will look down from this side and just eyeball it level, and I will almost tighten down the collet nut. Just eyeballing above the cutting bit and lining it up visually with the collet block. Doesn't need to be 100% on. Counter boring with a 6mm end mill, and if I didn't mess up anything, we shouldn't break with the counter bore into the cross hole, but we will see. Carbide end mill, 500 RPM, and some cutting off. Ooh. Yeah, maybe more like this. still doesn't feel very good. Let's slow it down a bit more. Okay, yeah, I should have run it from the get-go very slow, yes. Okay, I just cross-drilled the boring bar. That's the side with the drilled and tapped hole counterbore for a socket head screw, and that's the relief for the saw cut we're going to put in there. So let's flip it around once more against the stop, and now we're going to use our Morsepaper 2 saw arbor that we made in a previous video with a 1mm fine pitched saw blade, slitting saw. Okay, I centered the slitting saw. We're running it at 95 RPM. I will take a shallow pass across and we will come back and feed in. Whoops. Okay, there we go. Okay, you saw that was very uneventful, and we did a nice straight cut as it looks. So, piece of cake, and I could feed in pretty fast. And once you get somewhat of an appropriate feed, the noise of the saw blade also goes to a more subtle noise, and not that gurk, gurk, gurk. Then it's more like only on this channel, special sound effects. Okay, that's the first of the boring bars finished. Let me take out the screw. You see that the slit goes all the way through the 45-degree hole into the relief hole, and the cross-drilled hole for the screw with the thread passes barely against the hole for the cutting bit. Now when we put in the screw, we obviously can tighten down this. And when we now insert a 3mm high-speed steel blank, like this, and tighten down the screws very briefly, it doesn't really need much. It's safe in position. No way to move. No way to move this, and we have overhang to the side and to the front, so we can. When we grind an appropriate cutting insert or cutting bit, we can use this for to work up against the shoulder. Very, very nice. I like this design. And I didn't come up with this design. I saw this for this basic design with the screw in front here in a German forum published by Dominik. So thank you for showing us that. It's a pretty good design and I like it. So I copied it. Yeah, and this design with the push rod is of course courtesy of George H. Thomas. So I will finish the remaining boring bars off camera because it's always the same process. Drilling and running the slitting saw into it. And we will be back with grinding the insert, the cutting bits. Okay, now as the boring bars are finished, we are grinding the cutting bits that go in there, and I already have these four. I already ground cutting bits for these 4 boring bars, and I will show you how to grind them on the bigger boring bars as an example. The raw material is high-speed steel cobalt 12. That's the good stuff. 12% cobalt. These are high temperature and very hard. Even if they get blue on the grinder, doesn't matter. It's still hard as you can't anneal this with normal measures. Same for cobalt 8 and cobalt 5. So always make sure you get high-speed steel with cobalt. Without, waste of time in my mind. Yeah, and the dust from the high-speed steel grinding is toxic and will kill you, and cobalt is bad for your health, and so on and so on. End of safety briefing. These are single lip cutter blanks. That's the reason why they are already split to half at the end, but doesn't matter for us. We just want the round high-speed steel blank. We will start with the boring bar, with the 45-degree bore, with this one. And to make the grinding easier, we can use the boring bar as a holder. So we take one of the high-speed steel pieces, clamp it in the boring bar, so we have something to hold on when we're working at the grinder. So let's go to the grinder. Okay, we're at the grinder. This is an old bench grinder with 150mm wheels. And first step is to split the end of the high-speed steel to half thickness. We're just going to hold it like this against the grinding wheel, and I will tilt it slightly in that direction so we get a bit of rake. And the split it to half, it's not super critical. Okay, now we grind the front rake. We want clearance to the center, so we tilt it that way, and clearance to the bottom, so we tilt it back. Okay, and now for the side clearance. We want clearance in that direction, so we tilt it that direction, and back clearance, so we turn it slightly that direction. And that's it. That's all the grinding that has to be done on the bench grinder. Let's go back and hone the edges by hand. Okay, I hope you are able to see this. This is the cutting edge we just produced, and we have clearance to the center, like this, and back clearance like this, and there's some back rake here and here. So only the cutting edge is protruding, everything else is ground back, and now we're going to hone the edge slightly. I like these small triangular stones for this. This is a aluminum oxide stone, and I just work the side. I hold both parts freehand, not resting anything on the bench, only resting my hands on the bench. And I tilt the stone on the surface, and you feel when it sits flat on it, and then you just work the surface. Just like this. Doesn't need much. When the cutting edge gets shiny, you're good to go. Doesn't need any more. No need to get the whole surface cleaned. Same down here. Looks a bit awkward because I'm working around the tripod. And same here, cutting edge got shiny. And now for the top surface we can do the same, we just hit it lightly with the stone. And now we can put a small radii on the edge. I like to hold it that way, and you grind away from the cutting edge, so you don't pull out the burr onto the cutting edge. You want to pull the burr back. And then you just do this. And this is really hard to see on camera, but there is a teeny tiny small radius on the edge now. You only want the radius on the cutting corner, not on the cutting edges, because when you put a radius on the cutting edges, you dull the tool. It's not going to cut, or at least not with low pressure. And now we need to cut it to length. For that we could use a toy like this with the small cut-off wheels, but those these are rubbish. They cut so slow, and so there's a better way. Faster. First we have to determine the final length of the cutting bit, so we pull it back, clamp it, and we take our felt pen and make a mark here. And we pull the tool out, we get a big mess and a mark how long the cutting bit needs to be. So let's go to the bench grinder and cut this out. Okay, to cut them off we just grind the nick all around on the edge of the grinding wheel. Yes, you should not grind on the edge of the cutting wheel. But I do it anyway. Then you just go to your bench vise, clamp it up, and snap the overhang off. bit faster than using the tiny cutoff disc. Then you can clean up the end on the bench grinder again. Okay, that's all the boring bars. I hope that was somewhat useful. Oh, by the way, when you ask about the angles on the boring, on the cutting bits, doesn't matter. 5 degree, 7 degree, 10 degree, 15 degree, it works all. It's only a matter of tool life and surface finish. I generally shoot for 10 degrees in all direction. So 10 degrees clearance angle, 10 degree top rake angle, and 10 degrees relief. Relief can be a bit less, or back relief. Yeah, you know, the tool just should cut and not rub, so try it out. I'm not a big fan of advocating angles on cutting tools, because at the end of the day it doesn't matter. So thank you for watching, see you next time.